Space, the final frontier. We are in the distant future. These are the adventures of the new Starship Enterprise. Many light years away from Earth, it's on its way to explore new worlds, unknown life forms, and new civilizations. Galactic soap operas like Star Trek & Co. have been enthralling their fans for decades. The author's imagination knows no bounds. Not even Einstein's theory of relativity intimidates them. At first glance, the things they come up with actually seem plausible enough. But how much truth is there in these space sagas? What is science and what is fiction? One mainstay in the plots of these galactic extravaganzas is the manipulation of time.
Captain, ich empfange einen Notruf.
Auf den Schirm.
Hier spricht Commander Evans.
Unser Schiff sitzt in einer schweren
gravimetrischen Verzerrung fest.
Wir brauchen Hilfe.
Fenrich, können Sie das Schiff orten?
Die Position ist 516398. Die Entfernung 5 Lichtjahre.
Ist kein anderes Schiff unserer Flotte in Ihrer Nähe?
Nein.
Sie sind unsere einzige
Hoffnung. Helfen Sie uns. Die Gravitationswellen
werden sonst unser Schiff zerstören.
Tja. Die Nachricht kommt aus einer Entfernung von 5 Lichtjahren.
Now, this SOS is coming from a distance of 5 light years. That means it's 5 years old. There's no way we can help them. In this universe, nothing travels faster than light. 5 light years last 5 years. For a science fiction film, that's much too long. The answer would take 5 years to get back to the sender. That's why science fiction authors and filmmakers have to figure out how they can get around the natural laws governing this universe. For me as a physicist and science fiction fan, it's fascinating to see how they go about it.
This is the futuristic-looking transmission center at the Southwest German Broadcasting Corporation. Here, television programs are beamed up to a satellite and distributed around the world at the speed of light, 300,000 kilometers per second. On the left-hand monitor, the outgoing picture. On the right-hand monitor, the picture signal coming from the satellite. Both the images and the sound are delayed by fractions of a second. The transmission antenna is 36,000 kilometers away from the satellite. So, to go out and come back, the signal has to travel 72,000 kilometers altogether. The signal takes 0.24 seconds to cover the entire distance. Transmitting information takes time. We can see this more clearly in slow motion. Broadcasting pictures and sound at the speed of light. That was the basis for the triumphant success of the electronic media, television and radio. Here's Albert Einstein at the German radio exhibition in 1930, waxing rhapsodic about the invention of radio.
Verehrte An- und Abwesende, wenn ihr den Rundfunk höret, so denkt auch daran, wie die Menschen in den Besitz dieses wunderbaren Werkzeuges der Mitteilung gekommen sind. Der Urquell aller technischen Errungenschaften ist die göttliche Neugier und der Spieltrieb des bastelnden und grübelnden Forschers und nicht minder die konstruktive Fantasie des technischen Erfinders.
Nothing is faster than light. This pioneering insight on Einstein's part imposed an absolute speed limit on the cosmos. His other groundbreaking ideas really do sound like science fiction. Time is relative. It expands in the vicinity of massive objects like the Earth.
Dann schleichen wir uns mal langsam an die Relativitätstheorie.
Relativity theory describes processes taking place in space and time. We perceive those processes in space and time as well. The point is that relativity theory describes reality and not our perception of it. Einstein's theory of relativity turns physics upside down because it proves that reality is completely different from what we perceive it to be. To test the claims a theory makes, we have to conduct experiments. One of those would be to compare clocks in a field of gravity, one down here, the other at a certain altitude. And the results tell us that Einstein was right.
A tourist on top of a mountain will not notice that 10,000 feet up, his watch ticks just a tiny bit faster than it would down on level ground. The difference is so minute that it is completely irrelevant to our everyday concerns. But this effect of gravity is measurable, though only by the most accurate clocks in existence. The Federal Physics and Technology Research Center in Brunswick is the home of the Guardians of Time. Andreas Bauch and his staff devise and operate super-accurate atomic clocks. They tell the whole country exactly what the time is. Their timepieces are cesium clocks, deviating from an ideal clock by less than a millionth of a second per year. In an atomic clock, cesium is evaporated to produce two kinds of cesium atoms, differing in their energy levels, marked here in blue and orange. They are passed through a magnetic field, which filters out the higher energy orange atoms. Now, only the lower energy atoms are left. These cesium atoms are passed through an intense microwave field. The microwave generator attunes itself to the frequency at which the atoms change from the lower to the higher level energy state. This frequency, established with the aid of the cesium atoms, is the pulse rate of the atomic clock. At over 9 billion oscillations per second, it is extremely high. In this way, the cesium clock can measure inconceivably small timescales. The cable car's base station. Andreas Bauch and a colleague have agreed to haul one of their portable cesium clocks up to the summit of the mountain. We want to find out whether the atomic clock really does go faster up on the peak. Andreas Bauch is pretty sure that it will.
We'll leave the clock up on the mountain for 4 days. Back in Brunswick, we'll expect to see a difference of 120 billionths of a second between the clock up on the peak and another atomic clock that was down at ground level the whole time.
In preparing the experiment, Andreas Bauch has made use of Einstein's formulas. With their help, he can precisely calculate the deviation between the clocks in terms of altitude and duration. The outpost of the German Weather Service. They've been notified of the arrival of the atomic clock.
Grüß Gott. Grüß Gott. Können wir die Uhr für ein paar Tage hier lassen?
Measurements like this with atomic clocks are done at regular intervals to find out whether they really respond to differences in altitude in the way they've been calculated to.